Hello, Algebra 1B students for Mr. Fry. This is February 19th, and you guys did these in class. I'm going to do a few more than what you did in class in case you need them by next week, or in case the online students are doing a little bit more. I don't know, but I do every other one on the back, so stay tuned for that. Substitution method, a method of solving system of equation by substituting equations within another, is what you should have there. So step one, solve one equation for x or y. Step two, substitute this expression into the other equation and solve for the variable. Step three, substitute your answer into the revised equation from step one and solve for the other variable. Okay, what does that mean? Well, here we go. This one is different than all the other ones because it tells you y is equal to this and y is equal to this. So we could solve these two. They're both in slope-intercept form. We just set them equal to each other because it's saying that, y is going to definitely equal y because it's the same thing. And so if y could equal this and equal that, they are going to be equal to each other, right? So I just, isolate the variable on one side, end up dividing by 2, I get x equals -2. Once I figure out what the variable x is, then I'm going to plug it into one of the problems. I just chose the top one, and I put in for x, instead of x right here, I put in my -2 because I figured that x equals -2. So then I have 4 times -2 minus 1. And so that would be -8 minus 1 is -9. So there's my x and y coordinate, where they intersect, they would intersect at this point, -2, -9. Okay, taking a look at number 2. You guys did this in class also. 2 is telling you that the y equals 6x. So instead of y here, I'm going to just put in 6x and then work the problem out. I do the distributive property. 3 times 6 is 18. So then I combine my like terms. I divide -20 by 20 and I get -1. I go back in, and this was the easiest problem, so I put in for x -1 and I get 6 times -1 is -6. So your point of intersection, or the solution to this system of equations, is -1, -6. Okay, taking a look at number 3. I'm just plugging in this value in for y because it says y equals it. So I plug it in, and you can see the work that I did. And I end up getting -77 divided by 11 would be -7. I go ahead and plug -7 into one of the problems instead of x, and I chose the easiest one, and I get 2. So it's -7, 2. For number 4, this is telling me what x equals. I plug it in for x in this problem. Then I just combine my like terms. Now I'm just figuring out the y. And -2 divided by 2 ends up being -1. And pause this as you're writing all that down, obviously. Then I plug in my -1 in for y in the top problem, because that was the easiest one. Either one you do, and either one you solve, you're going to see you're going to get the same answer, because they're the same. They're going to intersect at the same. No matter which one you choose, you're going to get the same answer because that's where they intersect. Okay, there's only one point where they intersect, so you're going to get that same answer. You could try it. So the x is going to be 3. So the point at which they intersect, the solution to the system of equations, is going to be 3, -1. Remember, the x is always listed first, even though we solve for y first. On the back, didn't have to do these, but in case you end up doing these, you could take a look at these. I plugged it. First, you have to change this because I want to get what y equals all by itself. So you can see in the arrow, I just moved the 2x over to the other side and it becomes -2x. And then I plug it in for y in the 5x plus 3y problem. And then I solve for x. Once I solve for x, I substitute x in, and I used this problem because it was just the easiest, and I get negative 6. So the point of intersection for number 5 is 2, negative 6. That's the solution to the system of equations. Remember, the solution is just where they intersect. And here you're going to find that once you work this out, and I get negative 15y and a positive 15y, and they, when I combine them, I get no y anymore. I just get 12 equals negative 1. That is not so. Because that is not so, it's no solution. In other words, these are parallel lines. If I was to convert these both into equations that were slope-intercept form, you'd see that they would have the same slope. Having the same slope means they're parallel, so they're never going to intersect. That's why it comes out this way. Parallel lines, no solution. Number 9. Take a look at this. This one's interesting. I change, so I have just y on one side. I plug that in for y. I end up solving, and I get, 6 minus 6x, 6x minus 6x. I don't have x's anymore, so I just have 54 equals 54. Yeah, always true. So that's infinite amount of solutions. They're the same line. They're exactly the same equation. If I was to convert these, and think about this. If you take, let's take all of these and divide by 3. So 6 divided by 3 gives you 2x. 3 divided by 3 gives you 1y. 54 divided by 3 gives you 18. They're the same thing. They're the same line. This one's just multiplied by 3. If you're to put them both in slope-intercept form, you'd see that they're exactly the same line. So they have infinite many solutions because they're stacked right on top of each other. They're the same line. Number 11, I changed this one. I had to do a two-stepper because this was negative y. I don't want to know what negative y is. I want to know what regular y is. So I had to get rid of all the negative in this problem, so that changed all the signs to positive. Plug that in for y for this problem right there. And I solve, and I get negative 1 for x. I plug in my negative 1 for x back into this problem right here, because it was just quicker and easier. And 3 times negative 1 is negative 3. Negative 3 plus 8 is 5. So my solution to this system of equations is negative 1, 5. Hopefully this helps. And good luck with the even ones whenever you get around to them.